Hello friends. So hope you are fine and doing well by the grace of Almighty and by the blessings of your parents. Myself Muhammad Asif Iqbal once again with CSAT counting of figures. Friends, today we'll continue the another topic in counting of figures which is known as what? Square and rhombus. In this session we will see square and rhombus. How we can count number of squares in a given simple, moderate and complex figures, and number of rhombus in a simple, moderate and complex figures. So yes, we'll start it, friends. Yes, now before we proceed, okay, let us see just this one simple table. Fine. Now square. Now can we relate square and your rhombus? In square all the sides are equal. In square all the sides are equal. Now rectangle and parallelogram. Even in rectangle, yes. So opposite sides are equal. Opposite sides are equal. So yes, there is even trapezium, okay, isosceles trapezoid, kite and quadrilateral. Yes. So now in counting of figures, yes, what are the topics that we are going to see? We are going to see square and rhombus, parallel rectangle and parallelogram and quadrilateral. Fine. So these are the topics that we are going to see in the counting of figures. As of now in this session we will be seeing only square and rhombus. Sorry, square and rhombus. In the next session we will see this rectangle and parallelogram and so on. Fine, we'll move now, friends. Square now. So we have completed triangles. Now we will see how to count the number of squares in a given figure. Now friends, so let us study in this another topic, square now. Now fine. So this is a given figure. Now shall I say this is a window? Okay, window W. Okay, now in this window how many squares are there? Okay, fine. 1, 2, 3, 4 and the outer one. Shall I say 4 plus 1, which is nothing but 5? Yes, of course I can say 4 plus 1 is equals to 5. Now let us see in this. Now let us see. Okay, so this is 1, 2, 3, 4 and the outer one. Shall I say this as window 1? So yes, 4 plus 1, it is nothing but 5. Now in this, so again this is 1, 2, 3, 4 and given figure. So shall I say this is window 2, 4 plus 1, 5. So 5 plus 5, there is 10. Now whenever there is a window, okay, window in square, whenever there is a window, always 4 plus 1, 5. 4 plus 1, 5. If there is a concentric of window, just to check it out how many windows are there. Okay, fine. So in each window 5, 5, 5, 5. Let them give any number. Let them give any number of figure. Concentric window 5, 5. 5 plus 5, 10. Done. Over. We need not to again simple sit and count the number of squares in the given figure. So friends, so this is how we need to count the number of squares in window, especially window, in a single window, in a concentric window. Let them give any concentric windows. Now let us move on. Now friends, there is, yes, yeah. Now what do you mean by analysis? Yes, what do you mean by analysis? So the word analysis means the possibilities. Possibilities. Yes, possibilities. So we will be analyzing the respective topics: triangle, square, rhombus, rectangle, parallelogram, quadrilateral, yes, diagonal, straight lines and so on. So in that in the previous session we have already seen in triangles we have analyzed the triangles. We have seen the number of possibilities in which they can ask the respective question. Now we will see the number of ways in which they can ask the respective question in square now. Now look at friends here. Here there are two possibilities is there. What is that? One, r is equals to c. The another one, r is not equals to c. Fine. Row is equals to column and row is not equals to column. Now what means how I need to solve when row is equals to column and when row is not equals to column? Yes. Now let us see. Now first we will go through this row is equals to column. Yes. First we will see row is equals to column. Now here how many columns are there? 1, 2, 3. 1, 2, 3 and rows 1, 2, 3. So there are 3 rows, and 3 columns are there. Now if I just see the figure, so there are 9 squares are there. Yes. Apart from the 9 square, yes, there is a combination of single squares can form a bigger square. There is a possibility. We need to check it out. So this is 9. On screen I'm able to see, I can easily see 9 square. Fine. So this is 10, 11, 12, 13 and the outer one 14. So this is the possibilities of squares. Now we are preparing for competitive examination. We don't have time. So what is the simplest way that which we can solve this problem? Fine. So friends, look, this is very important. Okay. So whether r is equals to c or r is not equals to c, we need to multiply row into column. For example, here in this case r is equals to c. 1 square, 2 square, 3 square. 1 square, yes, 1 square, okay. 1 into 1, 2 square, 2 into 2, 3 square, 3 into 3. Why I am writing here 1 into 1, 2 into 2, 3 into 3? Why? Because so this is what first one, this is row, and second one, this is column. 1 into 1, 1, 2 into 2, 4, 3 into 3, 9, 9, 10, 14. Yes. So this is very important. 1 square, 2 square, 3 square and so on. Yes. 4 square, 5 square. So that square is there, right? Here we are saying row is equals to column, r is equals to c. When r is equals to c, when I am doing 1 square, it is nothing but first row, first column. 2 square, second row, second column. 3 square, third row, third column. In this way, even the entire combinations also came by default in that square method. So just yes, substitute the value and get the answer. Let us see another problem here. Okay, fine. So how many columns are there? 1, 2, 3, 4. 4 columns are there. How many rows are there? 1, 2, 3, 4. So I can say easily r is equals to c. Yes. So in this again r is equals to c. In this when r is equals to c, fine. Let us do 1, 2, 3, 4. So 1 square, 2 square, 3 square and 4 square. So again here 1 square, 1 into 1, 2 square, 2 into 2, 3 square, 3 into 3 and 4 square, 4 into 4. 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16. Yes, what's the answer? So 9, 10, 16 plus 4, 20, 20 plus 10, 30. Sorry, there are 30 squares are there in the given figure. 30 square. 1 square means 1 square, 1 into 1 is nothing but what? First row, first column. 2 square, 2 into 2 means what? Second row, second column. 3 square, 3 into 3 means third row, third column. 4 square, 4 into 4 means fourth row and 4 column. So in this way we can easily find the number number of squares in the given figure when r is equals to c. Yes, fine. So we will see some other examples wherein r is not equals to c. In that also you just remember only this one thing. What is that? Row is equals to column. Sorry. Yes. So in that you just remember this r into c. Whether row is equals to column or row is not equals to column, we need to multiply row into column. Let us see another example here. Fine. So friends, let us see the chessboard. We will take an example of chessboard. I hope you are very much familiar with the chessboard. Even the chess competitions is going on across in India, in national and international level. There is a competition, and even we know who is the the best chess sports person in India. So yes, it is Vishwanathan Anand, and even there are many other little stars are there who are competing in the mainstream competitor in the world of chess. So they are playing chess amazingly. Now friends, we will We will see how many squares are there. Friends, look at here. There is, now before I proceed, just I would like to tell you. So this is the chessboard. We know very well that there are number of, how many rows and how many columns are there? Of course, 8 rows and 8 columns are there in the chessboard. Okay, fine. Now there is a possibility of formation of square due to the combination formation of square due to the combination of single square. Yes, example I'm saying, this is one square. Yes, 3 rows and 3 columns. So this is this is the one of the possibility of formation of square. Okay, so here 2 rows and 2 columns and so on. So there is a possibility of formation of square due to the combination of single square. Now in this okay, now I will calculate, I will count the number of squares are there. So yes friends, here how many rows and how many columns are there? Here 8. Yes, 1 2 3 4 5 6 7 8. Yes, so there are 8 rows and 8 columns. 8 rows and 8 columns are there. Okay, fine. ठीक है. So now when 8 rows and 8 columns, so this is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square and 8 square. You do it, you will get the answer. You will around 204. Yes, around 204 you will get the answer. But in the competitive examination, do I have the time to sit and count even what you call to sit and add all these numbers? 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square. No, I don't have the time. I don't have the time, though I know this shortcut. I will move on for a better option. Then what is the better option? The better option is, yes, sum of square of first and natural numbers. Friends, in the natural numbers we have seen, in the natural numbers also we have seen, so types of numbers: natural number, whole number, yes, even, odd, integer, prime number, co-prime number, rational number, irrational number, and so on. Yes, in the natural numbers even we have seen the sum of first and natural numbers, square of first and natural numbers, yes, cube of first and natural numbers. Yes, if you when you do the sum of their square, cube and so on. So now this is nothing but 1 2 3 4 5 6 7 8. What? These are the natural numbers. So first and natural numbers square. So what is the formula that we know? We know n into n plus 1 into 2n plus 1 by 6. N into n plus 1 into 2n plus 1 by 6. What are, yes, what is n here? N is the number, yes, n is the number of row or column. So yes, look at here, n is what? 8 here. 8 plus 1 9. Okay, 2 into 8 plus 1, yes, by 6. So 8 9 17 divided by 6. Yes, 3 into 2 3 into 3 2 and the 2 4 the, you do it, you will get around 204. Yes, what's the answer? You will get around 204. Yeah, just substitute the value and get the answer you will get. So again, this is the better option rather than adding all the sum of square of around 8 natural numbers. So we are preparing for competitive examination, we don't have that time, so we will go with the better option here. Yes, so yes friends, so I hope it's very clear now. Fine. Now we will move on the next topic. Friends, now, yes, okay, we have seen R is equals to C when the row is equals to column. What happens when row is not equals to C? Let us see. Yes, so in this, yes, how many columns are there? Yes, 1 2 3 4 and 5. How many columns are there? There are 5 columns are there. And how many rows are there? 1 2 3 and 4. So there are 4 rows and 5 columns. Now, so yes, what is the basic funda in the square? Simple. R is equals to C. Row is equals to row into column. Now we will take row. How many rows are there? 4. Okay, 4 3 2 1. Okay, how many columns are there? 5. 5 4 3 2 1. Yes. Now look at here, just multiply row into column. 4 into okay, 4 into 5, 3 into 4, 2 into 3, 1 into 2, 0 into 1. Now yes, 4 into 5, 20. 3 into 4, 12. 2 into 3, 6. 1 into 2, 2. This is 0. Yes, look at it here. 6 plus 2, 8. 8 plus 12, 20. 20 plus 20, it is what? 40. 40. So how many squares are there in that given figure? 40. How many squares are there? So 40 are there. Now, okay, fine here. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let us take some other example. Okay, fine. Now, friends, I will show you some other method. Okay. Yes, whether r is equals to c or r is not equals to c. So this is one of the method wherein we can count the number of squares, row into column. R is equals to c, 1 square, 2 square, 3 square, 4 square, and so on. If row is not equals to c, just multiply r into c. Now, okay, we will go with the another simple and easy method. There is a possibility of asking the square in a different method, in a ladder method. How to solve that? While solving that, we cannot use this method to count that number of square. We will see to it. Fine, we will see to it. Look at here, friends. So yes, 1, okay, 1, 2, 3, 4, 5. 5 columns are there. 1, 2, 3, 4, 5. So 5 rows are there. So what here? R is equals to c. R is equals to c. I can do 1 square, 2 square, 3 square, 4 square. But there is another method. We will discuss it here. Look at here. In the diagonally, I have written 1, 2, 3, 4, 5. Now, okay, 1, 1, 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2. 3, 3, 3, 3. 4, 4. Yes. Look at here. Okay. So friends, look at here. 1, 1, 1, 1, 1. Okay. 2, 2, 2, 2, 2. Okay. 3, 3, 3, 3, 3. 4, 4, 4, and 5. Are you getting this pattern? Yes. Are you getting this pattern? So this is one of the simplest and the easy way. Yes, you just put it diagonally 1, 2, 3, 4, 5. Okay, then across its okay row and column, you just put 1, 2, 3, 4, 5 respectively. Now you add on. Okay, fine. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just add on all this. Okay. 1, 2, 3, 4, 5, 6, 7. 2 into 7, 14. 1, 2, 3, 4, 5. 3 into 5, 15. 1, 2, 3, 4 into 3, 12. And this is 5. Now you add it. Over. Done. Okay. 10, 20, 30, 30, 40, 50, 60. 60 over. This is one of the simplest way. This is another method. Okay, now when to use this method or when to use that method. Okay, now you will come to know very easily after this. Okay, you will understand easily, I hope, friends. So I made it very simple and very clear. Okay, this is another very interesting method with which you can use and solve the number of problems. So let us move on. Fine. Now if they give this type of problem, what will you do then? Yes, now in this you will use the technique which just now we have discussed it. Fine. So look at here, friends. Okay, so 1, 2, 3. Okay, again here also this is 1, 2. Now 1, 1, 1, 1, 1, 1, 1, 1. Okay, 2, 2, 2. Look at here again. 1, 1, 1, 1, 1, 1, 1, 1. 2, 2, 2, 2. Yes, 2 over. Yes, now if you see, look at here, friends. You add all this. Yes, 2, 2, 2, 3, 3, 3. Yes, add all this. 1, 1, 1, 2, 2, 2. Now, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many are there? So this is, okay, I will write it here. 9. Okay, 9. Add it. So, no, I will write it here only. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. 1, 2, 3, 4, 5. 2 into 5, 10. And this is 3. Add here 10, 20, 22. There are 22 squares are there, even including the combination in the given figure. If they give this type of figure ladder, okay, so then we need to, yes friends, look at here, very important. So diagonally you just put the numbers 1 2 3 4, let them give in this ladder any length, any length of problem, fine, you just put it there, you will get you can easily solve, friends. Yes, look at here. Yes, now 1 2 3 4 5 6 7 8, okay, this is 8, 1 2 3 4, 2 into 4, 2 into 4 8, 8 plus 8 16 over, so there are 16 squares are there, there are 22 squares are there, 16 square, 22 squares. I hope friend, very interesting, very simple and very easy. Yes, you will enjoy it. Now after this after the end of this concept, okay, you pick out the number of respective problem from any material. 101% I'm damn sure you will be able to solve it. That's it, done, over. Concept clarity is very important, tricks, yes, and idea is very important. Let us move on to the another one now. Yes, now friends, look at here. So this is another window here, okay. So 1 2 3 4 and 1, so how many squares are there here? 5 squares. Now here 5 square is there. If I see here, yes, so this is overlap, so 1 2 3, this is already overlap now, so this I need now to count it. Why? Because I have already counted here in this, so I will not count 1 2 3, and the outer one it is 4. If this is 4, now imagine this is 4 4 4 4 over, yes. Now look at here, so 1 2 3 4 5, 4 into 5 20, 20 plus 5 it is 25. Yes, how many squares are there? 25. How much time it took for you to just solve this problem? How much time? How much time it is? It takes less than 20 seconds or 15 seconds. Yes, so very interesting, friends. Now if they ask this type of problems, now look at here, now we will solve some of the conceptual interesting problems here, fine, okay, fine. So yes, once again just I would like to remind you, okay, destruct and construct, they will give a combination of figure 2 3 and 4, and they will what you call combination of 2 3 4 and make it 1. What we need to identify the standard figures, and we need to just dismantle it, okay, we need to see it separately, okay, count, add separately, and add all together respectively later on. Now yes, in the same way here also, in the same way here, okay, here, so 1 2 3, yes, so 3 into 3, so I can say this is 1 square, 2 square and 3 square. So 1 square is 1, 2 square is 4, 3 square is 9, 9 10 14. So in this yes, in this how many squares are there? In this 14 squares are there, in these 14 squares are there. Now there are other squares which are there at the corner, and the one corner is been shaded, actually one corner is been friends, okay, so this corner is been shaded, yes, this corner is been shaded, yes, shade, yes. Now okay, 1 2 3, and outer one it is 4, so here 4 means here 4, here 4, and here 4, 4 into 4 16, 4 into 4 16, 16 plus 14, yes, so 10 20, this is 30. How many squares are there? There are 30 squares are there in the given figure, over, done. Yes, so very simple and very interesting. Yes friends, like this you take the most important thing is you need to identify the standard figure, solve it separately, and add on later, you will get the answer. Yes, so we will move on now here. Yes, now if they give this this is one of the basic, we will gradually make it little complex also. Now if they give this type of problems, then how we need to solve it? Fine, look at here. So we know already this is okay. So this is 1 2 3 4 4 into, yes, just let me remind, 4 into, sorry, we are doing squares, right? Squares, friends. This is one more important and interesting I would like to share you. This is a trick, okay, how they what you call confuse us. Okay, so the same figure can be used to count the number of triangles, the same figure can be used to count the number of square, the same figure, okay, they will use in another, means what you call, in a combination of this kind of series to count the number of rhombus. Yes, so like this, yes, they will use. So question will be different and the figure will be different. Figure, it might look triangle, but the question is of square, so we get confusion, will fall into the trap. And the main objective of any competitive exam is to eliminate. So this kind of what you call traps, they will create it, and they would like to see how many of you will get out of this, identify and just bypass those trap, and how many of you will fall down. Most of them, they will get confused and they will fall down. So you need more practice. You need more and more practice to identify the trap and to bypass it very easily. Now, so this is what, look at here. If it is triangle, then 4 into 2, this becomes 8, 8, 8 here. Again 2, 2, 2. So 10, 20, 30, 38. So if it is triangle, then it becomes 38 triangles. How many triangles are there? There are 38 triangles. But we are not going through the concept of triangles. We are going through the concept of what? Square. Let us see squares. Okay, 1, 2, 3, 4, and here in between this is, yes, here this is, so again 4, this is 5, this is 6 and 7. How many squares are there? Clearly it is 7. It is 7 here. So if this is very simple and the basic one, if we move on to little moderate and the complex one, do we have the time to count the number of squares like this? No, we don't have the number of we don't have the time. So we will go with the 2n minus 1. What is the 2n minus 1? N is the number of square. You leave this, you just count the number of main squares, okay. So 2n minus 1, 2 into 4 minus 1, 2 into 4, 8, 8 minus 1, it is nothing but what? 7. So manually also while counting we got 7. Now using the simple what you call formula 2n minus 1 also we got 7. Now look at here, again we will see here. So how many squares are there in the given figure here? So here this is 1, 2, 3, 4, 5, 6, 7. So if this is 7, here, yes, in this is 7. Yes, 2n minus 1, 2 into 7 minus 1, 2 into 7, 14, 14 minus 1, 13. How many squares are there? There are 13 squares are there in the given figure. In the given figure, there are 13 squares are there. Let us count it manually. 1, 2, 3, 4, 5, 6, 7. 7. This is 8, 9, 10, 11, 12 and 13. 7, 8, 9, 10, 11, 12 and 13. Yes, you got it. Manually also we got it. 13, and while using this simple formula 2n minus 1 also we got it 13. So this, if the, we will see gradually, we will see in the next slide. So how this problem can be little more complex and how we need to solve that. Fine. Yes, we'll move on. Yes, now friends. Yes, now again, how many squares are there? Squares. We will restrict ourselves to square, but if we are seeing many triangles here. There. We are seeing triangles. The question is square. So at the back of the mind, there is a clash between the square and the triangle. So we should be very, very conscious enough to restrict ourselves to find the number of squares, then falling into the trap. Yes, square here. So in this, if you see here, so yes, this is 1, 2, and this is 4, 3 and 4. 1, 2, 3, 4. Yes. So 1, 2, 3, 4 and the overall one 5. Friends, here again I need not to count it here separately. Look at here. Simply I will say there are two windows. Yes. 1, 2, 3, 4, 5. So if this is a window 1, 5. Okay. And now there is another window here. Look at here. Again 1, 2, 3, 4 and 5. This is window 2. 5. 5 plus 5, 10. Over. Just now we have seen window. In a single window, how many squares are there? There are 5 squares. In window 2. Now, we have seen here two types. Concentric window. One is concentric window. Here, this is not a concentric. Here the window has, they have what you call, it is, though it is a concentric, but here it is tilted. Square in a square. It is 10. Okay, fine. Now, we will move on. Look at friends here. Up till here, this is similar. Yes, up till here this is similar, and how many are there? This is 10. If this is a 10, okay, fine, directly I will write 10. Directly I will write 10. Look at here. So, okay, this is 1. Oh, this is 2. Now look at here. This is a window. Okay, so this is 1, 2, 3. So this is already overlapped. I will need not to count 1, 2, 3 and the outer one. Yes, outer one. So 4. So this 4. This 4, this plus 2. 4 plus 2. How many? 6. 6 over. Now look at this. Now this one. Half of this and the other half which is been added together, I will get at what you call one outer square. So yes, 4 plus 2, 6, 6 plus 1, 7. Total 7. So now 10 plus 7, it is 17. So yes, there are 17 squares are there in the given figure. How many squares are there? There are 17 squares are there in the given figure. Let us move ahead. Let us move ahead here. Now friends, look at here. Now I will just divide it. I will make my job very easy here. Yes, up till here 10, 7, 7, 7. Over 7, 7. 7 into 3, 21. Add just 7 into 3, 21. 21 plus 10, it is 31. 21 plus 10, 31. Over. How many squares are there in the given figure? I need not to sit and count. So this is what we are studying, is we are studying the standard figures, so that it becomes very easy for us to solve the complex figure based on standard figures. Yes. So 7 into 3, 21. 21 plus 10, 31. There are 31 squares are there in the given figure. We have already what you call seen. Yes. Now let us take some other little more complicated problem. Fine. Now this is the given figure now, friends. This is the given figure. Now we need to count the number of figures. Now how will I do this? Okay, so that's what yes, remember this. Yes, destruct and construct. Very, 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 very important. Destruct and construct. Okay, so let us see here. I will tell you. Friends, look at here. Yes, this is the figure. This figure I have done separate. I have taken separately. Look at here. I took the entire this figure and have kept it aside here. Yes, I have kept it aside. What I left with this figure now. I left with this figure I have taken here. Yes, so this figure I have taken it here. Now solve it, it becomes very easy now. Look at here, this is the diagonal here. Okay, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, 2, 2, 2, 2, 2, 2, 2, 3, 3. Angle. Numbering is very important. The way of numbering and the counting is very important in the angle form. In the angle form. Yes. So that's what I have mentioned it here like this, in this angle here. Now count it. Now add all the 1, 1, 1, 2s, 3s, 4s and so on. It becomes very easy for our job. how many 2's are there? How many 3's are there? Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, how many are there? Either you count it horizontally, either you count it vertically, either you can't count in an angle way, you will get the same answer. You will get the same answer. Now look, 1, 2, 3, 4, 5, 6, 7. 2 into 7, 14. 1, 2, 3 into 2, yes, 6. So this is 20, 30. How many squares are there? In this, only in this figure, there are 30 squares are there. Now I will take the other figure now. I will take the other figure. Friends, just now we have solved this. Okay. 1, 2, 3. Now 1, 1, 1, 1, 1, 1, 2, 2, 2, 2. Over. Now 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. Now this, okay. Okay. Add like 1, 1, 1, 2, 2, 2, 3, 3, 3, and so on now. 1, 2, 3, 4, 5. 2 into 5, 10. So this becomes 3. Yes. So 20, 22. Now add this 22 plus 30. Yes. 22 plus 30, 30, 40. This is 52. Over. 22. Yes. 22 plus 30. It is 52. Just check it out. Check it out here. 1, 2, 3, 4, 5, 6, 7. Yes. So friends, now in this way, yes, in this way we will count the number of squares in the given figure. We will, what you call, we will just find, we will identify the number of we will identify the standard figures and we will separate it, count it and add it. Over. You will get the answer. Now we will move on. We will move on to the next problem. Friends, I hope I made it very simple and very easy for you to understand. Yes, there is another, what you call, if this is the big problem, okay, this is the bigger problem. Now a simple way, if they give the same problem, here's 1, 1, 1, 1, 2 here, okay, like this, in the angle form, so 1, 2, 3, 4, 5, okay, so 5 plus 2, yes, there are 7 squares are there, okay, 1, 2, 3, 4, this is 5, 6, 4, 5, 6, 7. Yes, there are 7 squares are there in the given figure. Now let us move on. Yes, friends, so this is how, okay, we need to count the number of squares in the given figure, and this is what the concept of square. Now square and rhombus, the concept of square and rhombus, the way we need to, the way how we find square and rhombus are same. Let us see in this session now. Yes, look at here. So this is 1, 2, 1, 1, again 1, 2. Friends, now what I am doing, you know, I am comparing square and rhombus. Look at here. This is the same example. This is the same example here. Okay, so again, what is our question? Our question is how many rhombus are there in the given figure. So 3 plus 2, this is 5. Again here 1, 1. So 3 plus 2, again it is 5. Yes, this is nothing but a window. 1, 2, 3, 4, 4. This is window. In window there are 5 squares are there. Now look at here. So this is 1, 2, 3, 1, 1, 1, 1, 2, 2. Okay, so 3, 4, 5. Here 5. 2 into 3 is 6, 3. Yes, so 10, 11, 11 plus 3, this is 14. Okay, otherwise this is one method. Another method is what? Yes, 1 square, 2 square, 3 square. 1 square 1, 2 square 4, 3 square 9, 9, 10. This is 14. Either that way or either this way, you will get the same answer. Look at here, friends. Here again 1, 2, 3. 1, 1, 1, 1, 2, 2. Okay, so look at here 3, 4, 5. So this is 5. 2 into 3, this is 6. Again this is 3. So yes, 6 plus 5, 11, 11 plus 3, again this is 14. Even for this rhombus also, you can what you call, apply that method. 1 square, 2 square, 3 square. 1 square, 2 square, 3 square. 1 square 1, 2 square 4, 3 square, 9, 9, 10, 14. 9, 10, 14. Look at here, friends. So this is 1, 2, 3 here. 1, 1, 1, 1, 2, 2, 2, 3. Add this here. Okay, 1, 2, 3, 4, 5, 6. 6. So 3, 4. 2 into 4, 8. 3 into 2, 6. 12 plus 8 20 over done. I hope friends, so hope you are enjoying, you are getting very what you call clarity, and you are very confident about now. Okay, so how to count the number of squares and number of rhombus. So yes, I am showing the similarity also, so that it becomes very easy for you to just what you call get a clear idea of square and rhombus both hand in hand. Fine. Now friends, let us move the other topic, sorry, other example. Now rhombus here. Okay, again same 1 2, yes, 1 1 1 1 1 2 2. So here count it, 1, this is 1 2 3 4 5 6 7, so 7 here, 2 into 3 6, yes, 13. So there are 13 rhombus are there in the given figure. Now here also same 1 2 3, 1 2 3 4 5 6 7 8 9 9, 1 2 3 4 5 6 7, 2 into 7 14, 3 3 4, 3 into 4 12, yes. So 10 20 20 30 35. How many rhombus are there? So there are 35 rhombus are there in the given figure. Friends, I hope you are getting the idea of rhombus as well. You are getting the why, the reason. Okay, in this ladder form, if they give the ladder forms, so we need to use this kind of numberings. Okay, so yes, very interesting, very simple. Now we shall move. Now friends, so look at here, this is a square. If I just tilt it, it becomes a rhombus. This I have already done here. Yes, 1 2 3 4, this is a single window, it is 5. If I tilt it here, it becomes what? Okay, this is 1 2 3, yes, this becomes 4. So 5 plus 4, it is nothing but what? 9. There are 9 squares are there in the given figure. Now this is a square. If I tilt it, it becomes what? It becomes what? If I tilt it, it becomes what? Rhombus. Same way. Okay, now 1 2 3 4, so this becomes 5. This is already overlap. 1 2 3, and the other one is 4 4 4 4 4, yes. So 9 10, again this is 13. Yes friends, so very simple and very interesting square and the rhombus. So I hope you got the clear cut idea. So again let us move. Yes, very interesting friends. Now yes, see, again it is little confusing here. We need to understand the trap, that they have given the triangle form and they are asking rhombus. So while looking at the figure, it seems triangle. At the back of the mind, okay, I need to solve rhombus. So there is a clash between the triangle and rhombus, triangle. But on means what I am seeing is triangle. So suddenly calculating from rhombus, there is a possibility that I may fall into the trap and I will count what you call triangle. So we need to be very conscious. Okay, so here I want only rhombus, not rhombus. Now yes, so let us see this one by one example. 1 2 3, and this is 4. Yes, 1 2 3 and 4. Now friends, how many rhombus are there? Let us count manually. This is 1 2 3. Okay, so 1, so this is 2, and this is 3. Now on screen we are seeing there are 3 rhombus are there. Okay, when I see here between these, the formation of 2 triangles, yes, there is a one line, okay, base line on that. Okay, there are one triangle, another one is inverted triangle. So shall I say this one line for one rhombus, another line for another rhombus, another line for another rhombus? Yes, means what? 1 2 3. Shall I say like this? Yes, I can say it. I can say. So how many rhombus are there? How many rhombus are there? There are 3 rhombus are there in the given figure. Now let us shift to second problem now. So again I need now to sit and count the number of rhombus here. What I will do, I will just count the number of these lines. This is 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 9. So how many rhombus are there? There are 9 rhombus are there in the given figure. Count it here. Okay, manually count. This is 1, 2, okay, 3, 4, 5, 6, 7, 8, and this is 9. Yes, manually also I got 9. While using this trick also I got 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got it. Now let me go to the let me solve the third problem now. Let me solve the third problem. I hope this much area might get what you call get cut in the on screen. Fine. So anyways, you just see here. I hope. Okay, fine. Now it's clear. Yes. Now again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many rhombus are there? 18. But see, the figure is getting larger and larger. What I mean to say is this, yes, this and this. Now figure is getting larger and larger and larger. Now if the figure becomes larger and larger, so then how many rhombus are there? Only the number of lines? No, even apart from that, there is a possibility of formation of rhombus due to the combination of single rhombus. Yes, look at here. So shall I say here 1? Yes, another one here. Yes, the same figure. Yes, so this is 1, 2 and 3. Look at here. Okay, now let me just solve the fourth one. Again we will come back to at 3 and again we will go to fourth. Now yes, first we will solve this fourth now. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, here 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. How many lines are there? 30 lines are there. So there are 30 rhombus. In addition to 30, is there any possibility of formation of rhombus due to the combination of single rhombus? Yes, there is a possibility. What are those possibilities? Let us just check it out. Okay. Okay. This is 1. This is 2. This is 3. How many are there? 3. Yes. Now this I have seen from this side. Okay. This is nothing but what? From northeast. Now let us see from northwest onwards. Okay. So this is 1, 2, 3. So how many are there? 3. Now let me see it from the top one. Okay. Let me see it from the top one. 1, 2, yes, 3. Now you just observe. Is there any pattern here? Yes, of course there is a pattern here. What is the pattern here? Look at here in this figure. At one side, if there is a single rhombus on combination of some few rhombus, so at one corner if it is 1, the other corner it is also 1, the other corner is also 1, the 3 corners of that bigger triangle. Here on the one side it is 3, on the other side it is 3, on the top vertex of that given triangle is also 3. 3, 3, 3, 1, 1, 1. So means what? In addition to this, as the figure becomes gradually bigger and bigger and bigger, okay, so there is a possibility of formation of rhombus due to the combination of few individual rhombus. Now I need now to sit and count here. Okay, so this and this, the other two sides, I need to just count the I just need to sit and count the what is the means how many rhombus are there at one corner. If it is 3, on the other side also it is 3. If it is 1, on the other side also it is 1. Over, done. I need now to sit and count here. So here it becomes 18. 18 plus 3, 18 plus 3, it is nothing but what? 21. Here how many are there? 30. 3. 30 plus 9, it is 39. So there are 39 rhombus are there in the given figure. Friends, I hope you have enjoyed it, and becomes very simple and very easy. Now it becomes very simple and very easy for you to count the number of rhombus. If they ask this type of figure, let them give what you call expand this figure. So just go through it once. Yes. Yes. So shall we move? Yes. So we shall move. Yes. Now friends, so this is what square and rhombus. So I made it very simple and very easy for you to solve the number, how to count the number of square and rhombus. So both are in the similar way. Yes. So now you take the problems from any material. Okay, use the basic. This is the basic standard concepts, fundamentals, okay, of square and rhombus. 101% I'm damn sure. So you will be able to solve problems on triangle, square and rhombus after watching this what you call this session. You will be able to solve triangle, square and rhombus from any material. 101% I'm sure. If you have any doubt, very well, you can just put forward in the comment section. So I will I will answer to those respective problems. So hope you enjoyed. I'm very thankful for your patience. So I'm looking forward for you in the next session. So thank you so much. We'll meet you in the next session with rectangle and parallelogram and quadrilateral. Rectangle, parallelogram and quadrilateral, or rectangle, parallelogram together. We will do it together. Fine. So until then, thank you so much. Yes.